quadratic formula and basically how to use it. Now, when you're solving quadratic equations when they're equal to 0, and so in this case you have them in standard form, ax squared plus bx plus c, you can solve it in quite a few different ways. If you're lucky, you can use factoring. If you are allowed, you can use graphing, because quadratic is just a parabola, and then you're just looking for the x-intercepts. So maybe you're lucky and you can use a graphing tool. You can also use completing the square, and completing the square is actually where this formula comes from. Now, if you've forgotten how to, for example, do that completing the square, I'll put up a link up above if you're interested on how to solve these equations using that, because you can do it in that way. You don't really need this formula. But for most students, at some point in grade 9 or grade 10, you will learn this particular formula, and then it will kind of stick with you. It's funny because this formula is one of the very few that I actually remembered for a very long time. Of course, I now am kind of interested in math, so it sticks around a little bit more because I come across it once in a while. But I'm pretty sure if you're going to continue in math, this one is going to be hard for you to let go of in terms of formulas, because it's pretty useful in solving for roots or for zeros, or actually for x in this particular equation. And the b, the a, and the c in the formula, as you can see, is just coming straight from the actual standard equation. So here's your a, so that's your a. Your a appears in two different places, so that's your a right there. Then you have your b, so here's your b, so your b also appears in a couple places, so that's b right here, right? So you have that. And then here's your c, and then your c actually only appears in one place, which is over there. Now, the key thing is, because when you solve these, you have this plus or minus. And if you remember completing the square, if you were solving by completing the square, at some point, you had to take the square root. And that's why the answer is going to be plus or minus there. So you really have two values for x that will solve this equation. The assumption here is that what you have underneath the radical symbol, so underneath here, so this, and I outline it right here, so it can't be negative, because we can't take a square root of a negative and expect to get a real number out of it back. So we're going to make the assumption that this is greater or equal to 0. Now, if it happens that it is negative, then basically what that tells you is that there is no answer for x. And that's also something very useful, if you come across that. And one of these examples that I'll have for you actually has it. Let's take a look and see, how to use this formula. For those students who want to really kind of take the next step, and I hope you do, and you want to know where this formula comes from, it comes from kind of completing the square, I'll make an extra video, and then when it's out, I'll put up a link to the derivation up above. For now, let's try to see if we can use it. So it's pretty simple to use, and instead of doing any factoring or doing any graphing or doing any completing the square, you just use the formula. So for instance, here is your a. Here's your b. Now the b always, and the a of course, and the c, they include the sign. So b here is negative 10. And then here's your c, which is positive 5. Now once you have these, you can just substitute them into the formula. So I'll keep the formula there, and I'm going to put this on the side right here. So for instance, I'm going to take the negative of b, so b is negative 10, so negative and negative, so that's going to be 10. Because I'm going to substitute this back in. Then it's going to be plus minus, all right? And then we have, this radical right here, so that we're going to try to put in here. I'm going to extend it all the way out. So b squared, so negative 10 squared is 100, so I'm going to keep this as 100, minus, and then now I have 4 times a, so that's going to be 8, and then 8 times 5 is 40, so this is going to be 40 right there. And then this whole thing is divided by, and then it's 2 times a. Now that's going to be 4 because a is 2. And that's going to be our answer. Now you can simplify this. So you have, for instance, 10 divided by 4. So you can change it to a decimal or reduce it to a fraction. So 10 over 4, so this is the same thing as 5 over 2, really. And then it's going to be plus minus, and then you have the square root. This is going to be of 60 divided by 4 right there. So we have our answer. Now, we have it here with the radical, but I mean, you can substitute it back into your calculator and then round them accordingly. Now, don't forget that it is plus or minus. So there's going to be two answers that you have. You have to use your plus first, and then you're going to use your minus second, and then you're going to have two answers to that first equation. Now, for the second one that you have, so let's try to apply the formula to this equation. All right, so that's what we have there. I'm going to just copy this just so that it's kind of within us so we can see it. So there you have it. And now let's try to substitute everything back in here and then see what we get. All right, so I'm going to get negative. So this is 12 plus minus. That's my b. Then I have, so under the radical, I guess I'm not going to make it as pretty this time around. So b squared, so that's going to be 12 squared, which is 144. Minus, now this is going to be 4. Let me maybe substitute all of them in, just so that you can see it. And now notice, so this is, the two negatives will be a positive. So underneath this radical, this right here, okay, so I can find out exactly what that is. I will cheat, I guess, a little bit. 144, so that's going to be positive there. Plus, and it's 4 times 3 times 7. So that's 228. So this is 228 under that radical sign. And then let's not forget we have the 2 over the 2a when a was 3, which is going to be 6. So this whole thing is divided by 6. So now simplifying this, so I have a 12 and a 6, so it's going to be minus 2 plus minus, and then the 228 divided by 6, and you can simplify that if you like. Now don't forget that you can also use your calculator if you wanted to find out what the answer is. That's how you actually use this, and it's most of the time it's useful when you can't factor, you can't graph, or and it's not very easy things that you're dealing with. If you can't factor right away, it doesn't pop out at you. You kind of use this formula. Now the last example I just want to show you what's going to happen is, I did this one on purpose. So for this example right here, you're going to notice that there's actually no solution. And the reason will be because if you try to substitute, so I'm going to, if I take this thing right here, all right, so that's what you see there on the screen. If you substitute in there, you'll notice you'll get a negative number underneath the radical. So for instance, the b is 5 for that example, so it's going to be 5 squared, which is 25. So we're going to have 25 underneath minus, and then notice 4 times a, now a is 1, and then c is 8, so 4 times 8 is 32, and so notice it's going to give us negative 7 underneath the radical, and we can't take the square root of a negative and expect a real number back. So therefore, this has no solution. So this formula is also useful for that, to be able to figure out quickly, is there a solution or not. Most students will unfortunately be kind of forced to memorize this formula because you're going to use it quite a bit in grade 10 probably, maybe even later on. And then that's all. And then most people don't even know where the heck this formula comes from. So as I said, you can click on that link before and then see where it's coming from. All right. But that's it. All right. So now you know how to use the formula. You can try it out on a few examples of your own. Thanks for watching. We'll see you in a future video. Bye, everybody.